Boston Dynamics' newest and coolest robots, as well as the history, evolution, and secrets of the world's most incredible robots. With an additional bonus, the company's fantastic but forgotten projects. Boston Dynamics was founded and led for nearly 30 years by Mark Ribert, who began as a professor at the Massachusetts Institute of Technology. At the school, Ribert founded the Leg Laboratory, dedicated to the research of active balance and dynamics in the creation of systems on the legs. And in 1992, he split from MIT to form Boston Dynamics. The new company needed funding, and the military provided it. Boston Dynamics created interactive three-dimensional computer simulations for them to train military pilots. Then there were some already forgotten but amazing robots. The six-legged Rise robot, capable of climbing up vertical surfaces and changing posture by adjusting to terrain with micro hooks on each leg and tail. The sealed robot with cameras for the military, Rex, is capable of traversing rocky terrain, sand, streams, mud, train tracks, and more. And the Sand Flea robot, with 4 wheels, capable of jumping up 10 meters, holding its position by using the wheels as gyroscopes. And also, who could forget Little Dog, a small research robot for robotics enthusiasts. But the most famous project for the military, and more specifically, the United States Defense Advanced Research Projects Agency, otherwise known as DARPA, was the robotic Big Dog, introduced in 2005 and became the first internet sensation of the company. Developed in collaboration with Foster Miller, the NASA Jet Propulsion Laboratory, and Harvard University. The robot was supposed to carry military cargo over rough terrain, but proved too noisy. The project was shut down in 2015, especially since Google, which bought Boston Dynamics in 2013, refused to sign new contracts with the military. But Big Dog was not a failure. Boston Dynamics used it to refine algorithms for all of the company's subsequent robots, including the Atlas robot. Big Dog's legs were equipped with hydraulic actuators, each with sensors to control joint position and force applied. Big Dog had a total of 50 such sensors, and the robot's onboard computer coordinated the position of the legs and the height of the body as it moved, monitored the force of the interaction with the ground, and distributed the load between each leg. This allowed Big Dog to adapt to surface changes. During its work with DARPA, the company managed to create several other robots. This is Alpha Dog, which is quieter and more robust than Big Dog, equipped with a stereo vision system and LiDAR. Alpha Dog Proto, with an improved legged square or LS3 support system, with a number of sensors allowing the robot to follow a human on rough terrain, avoiding obstacles, as well as self-propelled by GPS or following voice commands. Then there was also the robot Cheetah, capable of accelerating up to 46 kilometers per hour on high-speed treadmills, powered by an onboard hydraulic pump. The Cheetah autonomous model was named Wildcat, and it's the fastest 4-legged robot out today, capable of running at 32 kilometers per hour without losing its balance. The company's first human-like robot was Petman, which first appeared in 2009. The robot, created to test chemical defense suits, at first could only imitate human walk, but then learned to crouch, duck, crawl, and perform other actions just like a real person. And in 2013, Atlas, the world's most advanced anthropomorphic robot, was unveiled. The strong, agile, and maneuverable robot is not endowed with artificial intelligence, but can control its movements in real time. It does this with cameras on its head, 28 joints in its legs and arms, and many sensors located in the pelvis and all over the robot's body. They measure the robot's acceleration, its position in space, while moving, and other parameters of its interaction with the environment around it. The robot actively balances while walking, running, and doing tricks. It can use the force of inertia, sense the terrain through sensors in its feet, and adjust the force exerted by its feet on the ground. Every jump or somersault requires the robot to make a lot of calculation to keep its balance. Although Boston Dynamics engineers have created a library of pre-calculated motion paths for Atlas, the robot's control system constantly adapts to them and the current conditions in real time. All of the Atlas robot stunts have been hits on YouTube, and the last one was the Boston Dynamics robot dance on New Year's Eve. The company had been preparing for this video for a year and a half. Crazy, isn't it? The Robot World Talent Show gave Atlas a boost in development. The robot was upgraded structurally to become even stronger and learn how to perform all movements without stopping and with maximum energy savings. But most importantly, the robot's motion programming tools were improved. While in the beginning, the engineers had to work for over a month on the new system, but by the end, this period was reduced to 1 to 2 days. To learn more about how the Atlas robot was created, check the video in the tip. But back to the story. In 2015, Boston Dynamics unveiled the first version of the Spot robot, and 2 years later, it also revealed the first robot arm built for the robot. Today, Spot is openly available for sale, starting at $74,500 for the basic package. The robot is controlled by a tablet, reminiscent of a game joystick, and is able to move independently on a variety of terrain, changing its gaits as well as bypassing obstacles. For orientation, Spot uses 5 pairs of stereo cameras with a range of 4 meters, giving him a full 360 degrees. Spot's legs are powered by 12 decimal DC motors, 3 in each arm. The latest version of the robot, Spot Enterprise, has a more powerful processor, the ability to charge itself, as well as an improved robotic arm. At only 8 kilograms, the arm with 8 degrees of freedom can lift 5 kilograms. Simply point the robot to a lever to be switched or a door to be opened, and it grips and turns the object by itself. In this process, the robot will use its legs and body position to increase strength of its arm. You can learn more about Spot from the release in the video in the tip. But these aren't all of the company's robots. The Handle robot, introduced in 2017, was conceived as the perfect combination of legs and wheels in one robot. Handle was much simpler than the company's other robots. Finding no use for it in its original form, Boston Dynamics redesigned it into a nimble warehouse robot. But its slow speed and need for room to maneuver killed the robot as a commercial product in its infancy. But as a result of that defeat, a new robot from Stretch emerged. What makes it unique? First, the robot is based on Spot and Atlas. From them, Stretch has, for example, a machine vision system. They are 2D cameras with depth sensors and software that allows the robot to detect obstacles and boxes. The joints in the robot's arm, which has 7 degrees of freedom, are the same as those that Spot uses in its robot hips. Secondly, Stretch is much lighter than its current counterparts, traditional warehouse robots. It does not need to be bolted to the floor or manipulated to load. The robot does not require any special infrastructure and can work in any or less orderly warehouses, moving up to 800 boxes weighing 23 kilograms per hour. It can also unload boxes from a truck in the morning, move them inside the warehouse, and pallet them in the afternoon, and can load them on another truck for shipment in the evening. That is, the robot works where it's needed, any time of day. Stretch has its own vision system. It can detect, grab, and move boxes autonomously, moving in any direction and overcoming ramps. The robot's smart grip recognizes and works with all types of packages without delay. Thanks to its built-in monitoring and active control, a high-capacity battery provides 7 hours of battery life. But the robot can also be powered from the mains. While Stretch doesn't look as unique as the company's other robots, it could make Boston Dynamics a profit by becoming their second commercial product. In 2017, Google sold the company to Japanese conglomerate SoftBank, which in turn sold 80% of the company to South Korean tech giant Hyundai. The company itself looks at these changes with optimism. SoftBank's investment allowed Boston Dynamics to expand its staff from 100 to 300 people and launches sales and technical support for Spot. From Hyundai, the company expects engineering and manufacturing know-how, as well as the production capacity needed to scale up commercial robots. But most importantly, Boston Dynamics remains Boston Dynamics and continues to explore and create incredible robots. Subscribe to the channel, like this video, and share it with your friends. We'll see you next time on Pro Robots.